Hello, this is Chiban Acharya. I'm math professor here at FSW D Campus. In this video, I'll solve the questions from section 1.1 of statistics homework in MyLab Math. Uh, these questions are from MyLab Math, but I put them into the PDF format. And if you go to the MyLab Math, and you'll see the either exactly same questions or similar question with different numbers. Okay, so if you have a trouble doing homework in MyLab Math, you can refer this video and you solve the questions. And for example, in the uh, section 1.1, there is let's see, 20 homework questions, and those 20 questions here and the MyLab Math are either same or similar. Okay, so for example, again, if you go to question number 15 here in this video, and if you go back to the MyLabs question number 15 from this section 1.1, you got a similar question. Since it has a numerical value here, so this change maybe different numbers, 40 to 60 years, maybe 50 to 70 years, something like that, but you see exactly similar questions here in this video and in MyLab Math. Okay, so let's start with the first question, number one. This is about the definition of statistics, but make sure that before you answer this homework question, you got to read the PowerPoints, uh, or you got to read the textbook, or if it's possible, you may watch the publisher video from MyLab Math or in Canvas. Okay, so first question is about definition of statistics. So let me do that for you. Which of the following is not true of statistics? And read the option here. Statistics involves collection and summarizing the data. That's true. Statistics is about providing a measure of confidence in any conclusion. That seems to be true. Obviously, that's true. Statistics can be used to organize and analyze information. That is also true. And statistics is used to answer the question with 100% certainty. That's incorrect, because statistics doesn't answer the question with 100% certainty. So this is not the right answer. That means that's not true about statistics. Okay, the next question. Make a pen here. Next question about parameter and statistics. Statistic is the topics here. Number two, determine whether the underlying value is a parameter or a statistic. Parameter and statistics. There's two different words here. Parameter is numerical summary of population. Statistic is numerical summary of sample. So if you read the question correctly, in a survey conducted in the town of Atherton. So there is a survey here. So if you talk about the survey, this must be involved the sample, because population is entire group, so you cannot survey everybody in the population. So if there is involved a survey, this must be the sample we are talking about. So 28% of adult respondents reported that they had been involved in the at least one car accident. So 28% of this sample. So of how many there, we don't know, but 28% of that sample says they involve at least one car accident. So 28% is numerical summary of sample. So you can say summary of sample. So this is called a statistic. Question number three. Parking at large university, a very big problem. University administrators are interested in determining the average parking time, the time takes students to find the parking spot of its students. So that's what they want to determine, how much time students need to find the parking spot. So an administrator inconspicuously followed 140 students and carefully recorded their parking time. So here 140 is sample, okay, and they record the parking time for this 140 students. Identify the population interested in the university administration. So they survey only 140 students parking time, or to find the parking spot, how much time they took. But in the question, you got to identify the population. So the population must be entire students who park at that university. So the part C is the right answer here. Entire set of students who park at the university. Remember that B looks like convincing, but here entire set of faculty and staffs and students. So faculty and staffs is not the part of the population, because in the sample we choose 140 students, and also if you see here, administrators wants to determine the parking time for of its students. So only students is in the population. So entire students of the university who park is a population. Question number 4. A manufacturer of cellular phone has decided that an assembly line is operating satisfactorily if less than 0.02% of the phone produced cells per day are defective. So if 0.02% phone are defective per day, that's going to be satisfactory. So to check the quality of day production, look at here, they're talking about the day production. The company decided to randomly sample 20 phones from a day production to test the defects. Okay, they choose 20 phones as a sample to check the defect, and in this case also define the population of interest of the manufacturer. What's the population of interest on this case? In this case, the population of interest is going to be all this phone produced during that day in the question is going to be the population. If you look at the other one doesn't make sense, because 20 phone are not the population, that's the sample. So the 20 responses defective, not defective, not this population. So this is the statistic. This is not the 0.02% is not population. This is just statistic, numerical summary of 20 phones. So the answer is C here. Okay, let's do the next question here. Number 5. And here, similar question. You got to identify the sample of the interest, but it's same as last question here. Number 3 is parking of students question. So in this question, what is a sample? So in this question, sample is obviously 190 students are surveyed. So sample must be 190 students who had their parking times recorded. That must be the sample. Okay. Number 5 is done. Number 6. Which branch of statistic deals with organizing and summarizing of collected information? The organizing and summarizing or summarization of the collected information is done by descriptive statistics. Okay, it's just descriptive. Other statistics just different things. Number 7. Classify the variables as a qualitative or quantitative variables. Number of seats in the school auditorium. Number of seats going to be countable. You can count as 1 seat or 2 seat, like that. So this variable here, number of seats, is quantitative variables. The answer is this, quantitative variables. Number 8. Number 8. In this question, there is the table, student's name and their student number and their area of interest and their GPA. So you got to find there is what are the variables here. So and also type of the variables. Remember that student's number is a variable because they vary with a student's area of interest also vary. They are the variable. GPA are the variables. So you have a GPA variable, you have a area of interest variable, and you have a student's number variable. You have three variable, but you are looking for which one is what type of variable. In other words, which variable is quantitative or which variable is qualitative variables. So student number, even this has a numerical value, but this is the identification of the number. This identify the students, so this is qualitative variables. So students number must be qualitative variables. This is the qualitative, qualitative, and area of interest also qualitative variables, and GPA is quantitative variables. So for this question's answer is D, students number qualitative, area of interest qualitative, and GPA quantitative variables. Okay, that's the question number 8. Question number 9. How do quantitative variables classify individuals in a sample? Okay, how do quantitative variables classify? Quantitative variables based on the number. So this must be numerical measure of individuals in the sample. Okay, so this is what answer going to be. Question number 10. Determine whether the quantitative variables is discrete or continuous. Remember that quantitative variables also has a numerical value, right? Could have discrete or continuous. There's two types of quantitative variables. So and this question here, the number of bottle of juice sold in the cafeteria during the lunch, number of bottle, you can count this number of bottle is 1 bottle, 2 bottle, 3 bottle, like that. So this must be discrete. So if you count, this must be discrete. Okay, so it's pretty much discrete variable looks like 0, 1, 2, 3, like that. So this is the value of the discrete variable 0, 1, 2. But if the value is possible between 0 and 1 or 1 and 2 and so on, this variable is called continuous variable. Maybe we have another example, but this is discrete variables. Classify the following random variables. Telephone area code. So area code is numerical value, but this is identification or characteristics of an individual. So different individual has different zip code. So zip code gives attribute or characteristics of individual. It's not numerical value. Though it is represented by numerical value, but it's not numerical measure. It is attribute or characteristics. So question number 11, area code is qualitative data. So answer is C, qualitative data. Question number 12, determine whether the underlying numerical value is a parameter or a statistic. Again, you have to identify the value here. 43% is parameter or statistic. So parameter is numerical summary of population. Statistic is numerical summary of sample. So parameter is population. Remember that PP. Okay. Statistics is sample. Another word, statistics comes from sample. Parameter comes from population. So in this question, in the certain circle league, 43% of 14 team had won more game than they had lost. So 14 team here is the sample or population. That's what I'm looking for. So notice that 14 team here is a population, because it doesn't tells you out of how many 14, or they don't tells you a survey of 14 team. So it must be all 14 team in this question is going to be a population. So this is the numerical summary of population, 43%. So 43% of all 14 team. So 43% represent parameter, because this data set of all 14 team is the population. Okay, so number 12 answer is parameter, because the data set all 14 represent a population. Okay, number 13, determine whether the variable is qualitative or quantitative. That's question. Favorite music style. Obviously music style is not numerical measure, not the numerical value. So music style is qualitative variables. So answer must be D. The variable is qualitative because it is an attribute or characteristics. You got to also answer why it is qualitative, because it is attribute or characteristics of individual. Number 14, determine whether the quantitative variables is discrete or continuous. So look at the discrete or continuous. So here, width of the plank wood. Width is how thick the plank wood gonna be. Obviously thickness is measured in the inches or feet, so thickness is measured. Okay, width can be measured, not the count. Okay, not count. So as long as you count, it's called discrete. In other words, if you find the value of the variable by counting, like number of juice, number of car, number of points in the basketball game, like that, these are discrete. But if you measure, that can be continuous. So continuous variable can have decimal value, like 1.5 inches, right? Like that, like 1.5 inches or 2.6 inches. So if it is possible to have a decimal value, the variable is called continuous variable. So answer for this question number 14 is B. The variable is continuous because it is not countable. Okay, if it is countable, it's going to be discrete. Question number 15. A polling organization contacts 2449 adult men who are 40 to 60 years of age and live in the United States, and asks whether or not they had seen their family doctor within past 6 months. So this is the number of people, adult men, is a sample, because that many people are surveyed. Okay, remember the sample. In this sample, there are people between 40 to 60, and also they are the men, and they live in the United States. Okay, so they are asked whether you see the doctor past 6 months or not. So in this question, what's the population study? Population entire group, since this is the sample. Okay, entire group gonna be all adult male of 40 to 60 years of age who lives in the United States. So the answer must be C. Adult male or men who live in the United States who are between 40 to 60 years of age. Sample, the sample is 2,549 adult men who are 40 to 60 years old and live in the United States. So that's the sample. So that sample must be, let's see, the A. Here the answer choice, that's the population, sample. So this is question number 15. Let's do question number 16. Again, you have a data here, and you have a B, C, D, E. They are the setup of the television A through E. Okay, there is a television A, television B, C, D, E, and there's a size of the television and screen type of the television and the number of channel available on the television. So you got to identify what's individual in the being studied here. The individual being studied here is those television here are the individual, okay? INDIVID, individual, because we have collected the data from those television. These are called individual. So the answer is going to be those high definition television through A through E is the individual. So answer is B, the high definition television setup A through E. Okay. And what are the variables and their corresponding data being studied? So variables are size are the variables, screen are the variables, and the number of channel available are the variables. So the answer must be, let's find the answer here, size, number of channels, and the screen type. So the answer is A. Okay, again, size, what are the size here? You have a list of the size here in the parentheses. Screen type, again look at the screen type here. Screen type you can see in the parentheses, and the number of channel, those are the data which is available for those variables. So these individual 298, 120, 425, 270, 289 are the data for this number of channel variables. Okay, so that's the question A. Now determine whether each variable is qualitative or qualitative, continuous, or discrete. So size is a continuous variable because we can measure, right? We can measure size. Remember, the size could be what? Size could be 40.6 inches. You can make a television of this size. It's possible to make it like this size, right? So this is continuous variable because it's not countable. We cannot count size. We have to measure the size. Screen type is obviously qualitative variable. Qualitative variable because it is characteristics of each individual television. Number of channel is available is obviously this is discrete variables because you can count. Discrete variables because you can count. Question 17. A study conducted by researchers were designed to determine if application of the dog tip is as effective as cryotherapy in the treatment of common warts. Okay, so that's why researchers were designed to determine is that tip is effective for treatment of common warts. So they divided 57 patients into two groups. Okay, so they choose 57 patients, divide two groups. One is 29 patients, other group is 28 patients. So this is group 1, group 2. That's what they did. The 28 patients here in the group 2 use cryotherapy. This is cryotherapy. They did how do you spell it? cryotherapy. And the 21 people use applying duct tape. So they choose 57 people. They divide into two groups. Group 1 use duct tape, and the group 2 use cryotherapy. Okay, let's see what happens. And once the treatment is finished, it was determined that 66% of the patients in group A and 50% of the patients in group B had completed resolution their ward. So in this case, 66% people ward is gone. In this group B, 50% people ward is gone, right? So it looks like duct tape therapy is effective, right? That's what this question says. Now let's read the question here. What is the research objective? So if you read the option here, research objective going to be to determine if duct tape is as effective as cryotherapy in the treatment of the warts. Looks like it is here, but that's the objective here. Number two, what's the population being studied? What's the sample? So if you look at the population here, the population is entire group who has wart. So that's the population. Remember that not all people in the population, only those people who have a wart is the population. So all people who have a wart is a population. And the sample, obviously 57 people. We divide into two groups. That's the sample, 57. So number of people who are in the sample is 57. So 57 people with a wart. Notice that 57 patient with the wart is a sample. Okay. Of course 49, 29 and 28 is samples too, but we divided this into two groups, but the main sample is 57. That's the sample. So what is descriptive statistic? Descriptive statistics describe the data. So here, if you read it carefully, this is what do we get, the numerical summary. That's the descriptive statistics. It says 66% of the patient group A, group 1, and the 50% of the patient group 2 has resolution their warts. That's the descriptive statistics. Okay. Part D, what is the conclusion of the study? The conclusion study tells you 66% is effective in the ductive therapy. So it looks like ductive therapy is significantly more effective than the cryotherapy in the treatment of wart. That's going to be B. This is the conclusion, which is called inferential statistics. Inferential. Inferential statistics. Inferential statistics gives the conclusion. Okay, inferential statistics. So that's is for the next question. Number 18. This is fill in the blank question. You got to fill the blank from drop down menu, and is a numerical summary of sample. That is obviously statistic, statistic, a numerical summary of population, which is parameter, parameter, parameter. Okay. Number 19. Are the characteristics of individual of the population being studied? That's the variable. That's the definition of the variable, is the characteristics of individual of the population being studied. Number 20. I'll fill in the blank. N is a person or object, is a member of the population being studied. So that's the individual. Individual member. Individual is a person or object that is the member of the population being studied. If you look at the question here, like this question number 16, your A, B, C, D, we studied this television. This each are called individual. Okay, this is the part of the population. These are definitely part of the sample as well. Okay, all right. Thank you so much for listening this video. Bye.